The new Jurassic World Rebirth trailer just dropped, and there's one question everyone's asking. What is that terrifying creature lurking in the shadows? This bizarre new addition to the franchise has fans buzzing, and for good reason. We've seen some wild genetic experiments before, but this one might be the most unsettling yet. Let's break down what makes this creation so disturbing, and why it's unlike anything we've seen before. In Jurassic World Rebirth, we follow two groups that end up on a mysterious island with a dark history. There's a family who gets stranded there, and a team of mercenaries working for a pharmaceutical company called Parker Genix. This island seems to be a convergence point where dinosaurs released into the wild have settled, but it's also a location where InGen conducted some of their earliest genetic experiments decades ago. The trailer gives us glimpses of abandoned facilities, overgrown with vegetation, suggesting this island has been forgotten by time, or deliberately hidden. We see characters navigating through dense jungle and decrepit laboratories, creating an atmosphere reminiscent of the original Jurassic Park's sense of wonder mixed with dread. We've seen some scary creatures in this franchise, from the pack-hunting Spinosaurus to the massive Titanosaurus, but nothing compares to this new creation. The director seems to be taking inspiration from both creature features and body horror genres here, pushing the boundaries of what genetic science gone wrong can look like. Standing at what appears to be over 25 feet tall and likely weighing tens of thousands of pounds, this creature is unlike anything we've seen before. Just look at this thing. It has multiple sets of arms, not just the typical two limbs you'd expect. It walks on enormous knuckles with massive claws, and has this strange bulbous forehead that could serve any number of purposes. Maybe it's for echolocation like a beluga whale, or perhaps it's just a malformed skull common in embryonic development gone wrong. The skin texture appears uneven and rough, possibly indicating scales that didn't form properly or scar tissue from its difficult development. One thing's certain, this isn't anything you'd find in the fossil record. 6 limbs? A body structure that looks like someone threw a Star Wars Rancor into a blender with a mutant. This isn't natural evolution. This is genetic engineering gone horribly wrong. The trailer only gives us brief glimpses, which is a classic horror technique. Don't show the monster too clearly or too soon. But from what we can see, the D-Rex has a massive jaw structure similar to a T-Rex, but with abnormalities in the dental arrangement. Some teeth seem to protrude at odd angles, suggesting jaw development issues. Its eyes appear relatively small compared to its skull size, with a milky, possibly cataract-like appearance that adds to its unsettling look. So where did this creature come from? Let's explore a few theories. The first and most compelling theory is that this was one of InGen's earliest genetic creations, dating back to the 1980s. According to some rumors and alleged plot details, this creature might have been created before the genomes were further refined and sent to Site B for production. This theory makes sense when we consider that Rexy, the T-Rex we all know and love from the original Jurassic Park, was born in the late 1980s according to viral marketing materials. If this D-Rex was indeed created before Rexy, it could potentially be approaching 50 years old if it was made in the mid to late 70s, or at least in its 40s if created in the early 80s. That's significant because real T-Rexes probably didn't live much past 30 years. This mutant has survived far longer than nature intended, which speaks to its resilience despite its deformities. In biological terms, this is fascinating. Sometimes organisms with severe mutations develop compensatory adaptations that actually enhance survival in specific environments. The idea of an aging mutated dinosaur also adds psychological depth to the creature. If it's been alive for nearly half a century, isolated and aware of its own abnormality, what kind of personality or behavioral patterns might it have developed? Would it be more aggressive due to decades of pain from its malformations? Would it harbor specific resentments toward human researchers who created it and then abandoned it? The age of this creature also tells us something about the technology used to create it. Genetic technology in the 70s and 80s was drastically more primitive compared to what was available even by the early 90s, let alone today. Remember that scene from the original Jurassic Park where Hammond shows off their technology? Those CM5 supercomputers seen on Isla Nublar and Isla Sorna weren't around in the 70s and early 80s. The earliest genetic sequencing was extremely rudimentary, time-consuming, and error-prone. The first automated DNA sequencer wasn't even invented until 1986 by Leroy Hood, and early versions were slow and limited in capability. If more primitive technology was used to sequence and patch together dinosaur DNA, it might explain how this creature wound up looking the way it does. Scientists back then may have been working more on intuition and theoretical frameworks rather than precise genetic mapping. To be clear, InGen scientists weren't planning for it to look like this. This animal was probably a failed attempt at creating a T-Rex. The 1980s represent a fascinating period in genetic research, after the initial breakthroughs of the 1970s, but before the sophisticated tools of the 1990s. It was an era of ambitious experimentation with limited tools, exactly the kind of environment where spectacular failures might occur alongside groundbreaking successes. Let's understand the genetics behind this monster. There are things called Hox genes, clusters of genes that control the basic body plan of any animal. They're like the architectural blueprint that determines where limbs go, where your head develops, and the general layout of your body. These genes are incredibly ancient and conserved across species. Mutations can change the shape and size of limbs, which is how evolution happens. But these genes are hard-coded so that the body configuration stays consistent. That's why tetrapods like us and every other land vertebrate have never naturally developed limbs where our heads are, or arms sticking out of our legs, or more than 4 limbs in over 300 million years of evolution. Natural selection has preserved this basic body plan because it works. Simple gene splicing shouldn't cause what we're seeing with the D-Rex. Adding frog DNA to fill gaps in dinosaur DNA, as described in the original Jurassic Park, shouldn't result in extra limbs or drastically altered body structures. So what could explain it? The answer might be a rare condition called polymelia, a mutation that affects the Hox genes. This happens when there's a mistake in the DNA that causes the Hox genes to duplicate or change, leading to problems with the animal's body structure. In nature, this can occur through environmental factors like radiation, chemical exposure, or random errors during embryonic development. In real animals, polymelia usually results in non-functional extra limbs. We've seen cases in livestock, amphibians, and even humans where additional limbs develop, but they're typically smaller, malformed, and not useful for locomotion or manipulation. What makes the D-Rex particularly terrifying is that its extra limbs appear to be functional, suggesting a more complex genetic alteration than typical polymelia. In this case, the early InGen geneticists likely botched the DNA rebuilding process. They may have accidentally introduced duplicate Hox genes or damaged the regulatory regions that control when and where these genes are expressed during development. Notice that everyone online has been calling it a mutant. Not a hybrid, not an amalgamation, but specifically a mutant. This has important implications for understanding its origin. When an animal undergoes mutation, any extra limbs or features often appear asymmetrically. Think of real-world examples like Stumpy, the 4-legged duck, who was born with an extra 2 asymmetrical limbs, or the octo goat born on a Croatian farm with a total of 8 legs. These additional features typically don't follow the body's normal symmetrical development patterns. The D-Rex seems to have gone through something similar, developing 2 extra large limbs that allow it to knuckle walk, plus 2 smaller limbs with 2 digits each, similar to the tiny arms of an actual T-Rex. But these elongated front limbs aren't present in any real T-Rex fossil, so what happened? Remember that in Jurassic Park they mentioned using frog DNA to fill in the gaps in dinosaur genetic code? That could explain the D-Rex's unsettling appearance. Frogs famously undergo metamorphosis, where tadpoles start growing limbs as their tails shrink during maturation. This developmental process is controlled by specific genes that activate at particular times. If these amphibian genes were improperly integrated into dinosaur DNA, they might have triggered abnormal limb development. Perhaps the genetic instructions for growing frog legs were activated in multiple places during the D-Rex's embryonic development, resulting in additional limbs. The knuckle walking posture could be the creature's adaptation to support its massive weight with these unconventional limbs. From what we can see in the trailer, the D-Rex appears to have bilateral symmetry, meaning both sides of its body mirror each other. This would actually be extremely extremely rare in a naturally mutated animal, which suggests this was either an engineered mutation or the result of a systematic genetic error that affected both sides of the body equally during development. The fact that this creature survived at all is remarkable. Most embryos with severe mutations die before birth or shortly after. The D-Rex's survival suggests either remarkable adaptability or perhaps ongoing genetic interventions during its early development. In the trailer, we can see one of our heroes, Duncan, luring the D-Rex away with a flare. This aligns with the theory that this creature was indeed an early attempt at making a T-Rex, since both this mutant and Rexy are attracted to flares. This behavioral similarity suggests that despite its physical differences, the D-Rex retained some of the neurological and sensory characteristics of a T-Rex. The face of the D-Rex shows features similar to a T-Rex with a wide jaw resembling T-Rex mandibles. Even with compromised jaw mechanics, the T-Rex would still be formidable. T-Rexes had among the strongest bite forces of any land animal in history, estimated at around 8,000 pounds of force. Interestingly, the build of this animal creates some logistical problems for traditional predatory behavior. At its speculated height, if the D-Rex wanted to bring its jaws close to the ground to eat a human, it would have to spread its front limbs to the sides to lower its head. This awkward posture would make it vulnerable during feeding, a problem that real T-Rexes didn't have with their bipedal stance. This biomechanical challenge leads me to believe that this mutation forces the animal to use its front limbs as its main weapons, with the two-digit hands serving as striking or slashing weapons, only using its jaws at very close range. This would represent a significant departure from typical theropod hunting strategies. Rather than the bite and shake method employed by most large carnivorous dinosaurs, the D-Rex might use its multiple limbs to grab, immobilize, and tear apart prey before bringing it to its mouth. The only reason this creature would be an effective predator is because of its sheer size and reach. Its unusual body plan would likely make it slower and less agile than a properly formed T-Rex, but with multiple grasping limbs, it might not need speed, just the ability to ambush and grab prey with its numerous appendages. Speaking of size, let's figure out why this animal ended up being so massive despite its base genome being a T-Rex. Our theory is that because the Hox genes were corrupted during embryonic development, the affected gene cluster might have influenced growth-related genes, not only adding additional limbs, but also affecting the size of these limbs. The height of a T-Rex is largely due to its hind limbs. During the D-Rex's embryonic stage, the Hox genes that normally influence the number and length of limbs resulted in polymelia, causing multiple oversized limbs to develop. The mass of the body, torso, and head is likely similar to a normal Jurassic Park T-Rex. It's primarily the limbs that were affected. This abnormal growth pattern may have continued throughout the creature's life. Normal animals have genetic mechanisms that tell their bodies when to stop growing. These are called growth inhibitors. If these regulatory genes were damaged during the D-Rex's creation, it might have experienced prolonged or excessive growth, explaining its enormous size. Hox mutations sometimes lead to something called neotenic traits, where certain juvenile characteristics are retained into adulthood. This could explain why the D-Rex retained a bulbous-looking head and a strange natal form on its upper torso as it matured. Neoteny is seen in various animals in nature. Axolotls famously retain their juvenile gills into adulthood, and even humans show neotenic traits compared to other primates, with our relatively large heads and flat faces. There's a fascinating scene in the trailer that shows what appears to be a flashback to when the research facility was still operational. We see what looks like a younger version of the D-Rex observing a scientist. What's particularly interesting is that this younger D-Rex seems to be taking its time, not rushing to attack the individual. This suggests that even as a juvenile, this creature displayed traits of a shrewd, calculating predator, learning about its world as it grew. If the D-Rex has been alive for decades, it's had ample time to learn about its environment, understand human behavior patterns, and develop sophisticated hunting strategies. Unlike newly created dinosaurs that might rely purely on instinct, this creature has decades of experience and learning to draw upon. What does this mean for the mature D-Rex we'll see in the movie? Perhaps an even more frightening, intelligent, and potentially malevolent monster than we expected. A creature that doesn't just hunt by instinct, but learns, adapts, and maybe even holds grudges. This psychological dimension could elevate it from mere monster to genuine character. A being with motivation, memory, and perhaps even a desire for vengeance against those who created it and then abandoned it to its fate. there's an alternative theory worth considering. Based on some hints in the trailer, we might not be looking at an ancient InGen creation at all. Some of the technology seen in the laboratory scenes doesn't scream 1980s, but rather suggests a more recent timeline, closer to the 2010s. If Parker Genix, the pharmaceutical company mentioned in the film, took over this island, similar to how Manticorp in Camp Cretaceous and Masrani Global acquired other InGen locations, then we could be looking at a much more recent experiment. If this mutant was created in the modern era, was it actually an accident, or was it engineered to be this way? Modern genetic tools like CRISPR allow for much more precise genetic editing than was possible in the 80s. A mistake of this magnitude would be less likely with contemporary technology, suggesting potential intentionality behind the D-Rex's design. Hox's genes can be and have been tampered with to create custom augmentations in animals. Just recently, an Argentinian biotech company created a genetically modified horse that was augmented to run faster. The entire genome of this horse was modified and completed before the animal even underwent gestation. The genes that developed the appropriate muscles allowing faster acceleration were precisely targeted, creating a horse significantly faster than the champion polo pony that served as its genetic base. Using this logic, there's a chance that Parker Genix knew exactly what they were doing. By targeting the appropriate genes and identifying those that control limb development, bone length, and muscular structure, they could have intentionally created this monster. This raises disturbing questions about motivation. Why would anyone deliberately create such a creature? Military applications are an obvious possibility. The franchise has explored this theme before with the Indoraptor in Fallen Kingdom. A massive, intelligent predator with multiple grasping limbs could be seen as a biological weapon. Alternatively, pharmaceutical companies often seek unusual biological compounds for drug development. Perhaps Parker Genix believed that extreme genetic manipulation might produce organisms with unique biochemistry, new proteins, enzymes, or hormones that could be harvested for medical applications. This might explain why the entire mission to retrieve 3 large animals from the island could just be a cover story. Perhaps the real objective is to reclaim a valuable genetically altered asset, one that laid waste to the lab long ago but is now being sought after by its creators for its biological secrets. The D-Rex embodies the Jurassic franchise's consistent theme of human hubris in the face of nature. Whether it's an old InGen mistake or a deliberate modern creation, it represents our tendency to push scientific boundaries without fully understanding the consequences. Dr. Ian Malcolm's famous quote from the original film seems particularly relevant here. Your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should. The D-Rex is the physical manifestation of this warning, science pursued without ethical guardrails. If the D-Rex is indeed decades old, it also represents the long-term consequences of our actions. This opens up fascinating philosophical questions about responsibility. Does InGen or its successor companies have an obligation to this creature they created? Is it ethical to hunt and kill it when humans are responsible for its existence and condition? Whether the D-Rex is an early InGen mistake or a modern creation deliberately engineered by Parker Genix, it represents a new level of terror for the Jurassic franchise. A creature that combines the predatory instincts of a T-Rex with mutations that make it larger, more disturbing, and potentially more intelligent than anything we've seen before. The Jurassic franchise has always played with the theme of life finds a way, showing how genetic tampering leads to unexpected and often disastrous results. The D-Rex embodies this theme more dramatically than any previous creation, demonstrating the horrifying possibilities when humans play God with genetic code they don't fully understand. As we await the release of Jurassic World Rebirth, we're left with many questions. Will the D-Rex be portrayed as simply a monster to be feared? Or will the film explore the deeper implications of its existence? Will it have developed a complex psychology after decades of isolation? And most importantly, will this monstrous creation prove to be the ultimate predator, or will it, like so many other genetically engineered creatures in the franchise, ultimately demonstrate that nature cannot be so easily controlled? I guess we'll find out when the movie hits theaters. If you enjoyed this analysis, don't forget to like and subscribe for more deep dives into your favorite movie monsters. Thanks for watching, and I'll see you in the next video.